This is the continuation of the second part of the polynomial operations lesson for Chapter 9 in Algebra 2. And we're kind of picking up right where we left off. We are looking at dividing with fractions, which really just requires one extra step from what we had before. Hopefully you remember that when you divide by a fraction, you really are multiplying by the reciprocal. So the only thing that's really going to change here is before I start my problem, I'm going to take this second fraction and flip it over. So I'm going to make it a 6y over a 12x to the 9th. Get rid of that. And now I'm thinking about this like multiplication. Remember, when you're multiplying fractions like this, and these are all single terms, I can go through and cancel anything on the top with anything on the bottom. So, for example, I have a 3 and a 12. Which I know can both be divided by 3. So I'm going to divide this by 3 and make it a 1, divide this by 3 and make it a 4. Okay, now let's look at my x's. I have x squared and x to the 9th. So 2 of these x's would cancel with 2 of these, and I would be left with an x to the 7th. Let's go this way. So 6 and 2 can both be divided by 2. That would leave me with a 3 and a 1. And then I have a y with a y to the 5th, so one y would cancel out, and this would become a y to the 4th. Now the one I always forget to check is up and down. I have a 1 and a 1, that nothing happens there. I mean, I guess it would if it was something other than a 1, but those two things are going to cancel each other essentially. And then 3 over 4 doesn't reduce any farther. And I don't see any x's and y's top and bottom that are left. So let's go ahead and start multiplying straight across. This was pretty much wiped out. There's not anything left here, okay? And then here, all we're left with is a 3. So up on the top of my fraction, the only thing I have left is a 3. On the bottom, I have a 1 times 4, so that's going to give me a 4. And then I see a y to the 4th and an x to the 7th. And that would just be my final answer. Okay, I would double check and make sure there's nothing else here that can reduce. I don't see anything because we did all our reducing ahead of time. So now let's look at that second one. And again, when you see division, all we need to do is take this fraction and flip it over. Now we've got some things that are in multiple terms here. So I just want to remind you that you can't cancel out pieces of a multiplication, or I'm sorry, of an addition problem. I can't cancel like just this x with just this x. But I can take an entire parenthesis, which is being multiplied by another parenthesis. I can take one entire binomial and cancel it with another binomial as long as it's identical. So, like for example, here I see an x to the 5th, which can cancel with, now here I actually have 2 copies of x to the 5th, so I can just get rid of 1, so that I have now just a single x to the 5th. And then here I have a 2x plus 1 that can cancel with this 2x plus 1. That's it. Those are the only things I can cancel. So up on the top here, I have an x to the 7th with an x. So I'm going to write that as x times x minus 7. And on the bottom, let's see, that whole thing's gone, and so all I'm left with is an x plus 5. I cannot go any farther than this because I cannot cancel this x with either of these x's because this is connected to that 5 with addition, okay? These things are like locked together, so I can't cancel a single piece of this. The only way I could cancel this out is if I had another copy of an x plus 5 sitting up on top, and I don't. So this is as far as I can go. Okay, before we get into fraction addition, I do want to go back and look at some of these problems that I gave you up at the beginning. Okay, so first off, I just want to remind you that when you're doing addition and subtraction with fractions, you need a common denominator. Now, in this first one, I have a common denominator already, which is awesome. That makes life easier. And remember, when you're doing that, you're only adding together the numerators. So 1/5 plus 3/5 gives you 4/5. Okay. When you don't have a common denominator, you need to make one. And so I would look at this and say, well, 5 and 2 both go into 10. So I want to turn these things into 10s. And here I would have to multiply by a 2 to get that 10, which means I'm going to multiply by 2, whoops, up on the top as well. And that's going to give me 2/10. On this side, I need to multiply by 5 and multiply by 5, and that's going to give me a 15/10. And now that I have that common denominator, I can just add the tops together and say this is 17/10. Now I want you to notice what happened here is really I just took this fraction and multiplied it by that denominator, and then this fraction got multiplied by that denominator. That will always work. Okay, you can always just pick that bottom number and multiply the other side by it. The thing is, sometimes you can get away with a smaller number, and I'm going to show you that in this next example, because if I were to go to this next one and just multiply over here by 225 and then multiply over here by 105, I would get a common denominator. Those numbers are going to be gigantic, but if you're okay with that, if you're okay with taking the time to do all that reducing at the end, that's okay. I want to show you something you could do to avoid having to do that. So what I want to do is I want to think about what is this 225 made up of? I'm almost making like a factor tree, and if it helps you to make a factor tree off to the side, you certainly could. But I want to take that 225 and break it down into its factors. So 225, I know that 5 goes into it. So it's 5 times something. And actually, sorry, I'm using my phone as a calculator right now. But 225 divided by 5 is 45. So now let's take that 45 and divide by another 5. And I have 9. So now what goes into 9? Whoops, can't see that. I could divide it by 3, which leaves me with just a 3. And so just to double check, if you do 5 times 5 times 3 times 3, it should give you 225. And if it's easier for you to write that as a factor tree to kind of keep track of those numbers, you're welcome to do that, okay? So, but this thing is equivalent to 225. Now let's do one for 105. So 105, let's see. I can divide by 5, I know. So it's 5 times 21. So now that 21 can be divided by 3. And that leaves me with 7. And I can't go any farther because 7 is prime. So really what I just did is a prime factorization. Okay? What I'm looking for here, the reason I'm doing this, is I want to see what do these numbers already have in common. And you'll notice that both of them have a 5 and both of them have a 3. Okay? Which means that this side only needs this 7. Okay, we have to multiply by 7 over here because that's what this one is missing. That's what this side has that this one does not. Over on this side, I need a 5 and a 3, which is really a 15. So I'm going to multiply by 15 on each side. And what that's going to do for me is not just give me a common denominator, but it's going to give me the least common denominator. It's going to give me the smallest possible denominator I could use, which is going to save me from having to simplify at the end. So that's going to give me 77 over, let's see what 7 times 225 is. 1575. Plus 15 times 17 is 255 over, well, let's double check this. 105 times 15 should work out to be 1575. It does. Okay, and so I ended up with my common denominator that is smaller than what I would have gotten if I would have just multiplied by 225 and 105. So now really all I need to do is 77 plus the 255, and I end up with 332. But the beauty of this is if I did truly find my least common denominator here, I shouldn't have to do any reducing here at the end. Okay, so if you like it the other way, if you like to just make your numbers gigantic and then break them all down at the end, that's okay with me. Okay, but one way or another, you have to get your fractions simplified. So again, if we can limit how large we're making these numbers to begin with, that's going to save us from having to simplify later. All right, so let's apply that to this. So like when I look at this first one, I need a common denominator. Now 2 and 5, now we're going back to that really easy one that we talked about. I want to turn these both into tens. So I'm going to multiply on this side by 2. And I'll multiply on this side by 5. And that's going to give me 15x over 10 plus 6y over 10. Now, I can't actually add these together, right? They're not like terms, but I can write it as one fraction. So I can write it as 15x plus 6y all divided by 10. Okay, so this next one is where that common denominator piece is going to come in. And this one's going to be easier than the one we just did. Let's look at this first, and I see a 4 and an 8. Well, I can turn a 4 into an 8 really easily, so I don't have to mess with the 8 at all. I may have to mess with the x's and y's, but I can multiply on this side by 2, and I know that'll get me, that'll turn the 4 into an 8 so that the denominators match. Now let's look at the x's. This side has 1x and this side has 5. I can't reduce the number of x's I have, but I can multiply by some x's to make this one match that one, right? So I can make this into an x to the 5th by multiplying by an x to the 4th. Oh, you're not going to be able to see what I'm writing here, sorry. So, oh, that dot is in the way. So I'm multiplying by a 2 and an x to the 4th, which means I'm multiplying by the same thing on the top, a 2 and an x to the 4th, because I'm trying to make this match this one. Now, for the y's, this one has 2 y's and this one only has 1. I can't make this smaller, but I can add a y over here. And I'm saying add a y, but I'm really multiplying by that y. So I'm going to multiply by a y, top and bottom. So watch what's going to happen. On the top, 2x to the 4th times 3 is going to give me a 6x to the 4th. On the top of the other fraction, 7 times y is 7y. And then in the denominator, I kind of jumped and put this all together all at once, but I'm going to have an 8. So 2 times 4 gives me 8. X to the 5th, and then a y squared. And if I wanted to check over here, this would give me 8 x to the 5th, and then y times y would also give me y squared. So that denominator would be the same. Okay? So again, if you really wanted to, you could multiply this side by 4xy squared, and you could take this side and multiply it by 8x to the 5th y. But that's going to leave you some simplifying that has to be done at the end, and that might get to be kind of a mess. Okay, so with this next one, if I think about the prime factorizations of 9 and 10, 9 is made up of 3 and 3, 10 is made up of 2 and 5, so they have nothing in common. Okay, the best I'm going to be able to do is to turn them both into 90s, which means I'm going to multiply on this side by 9, and I'm going to multiply on this side by 10. As far as variables go, this one has 2 a's and this one has none. So I need to get some a's over here so that these two things can match. This one has 5 b's and this one has none. So this one needs some b's. And essentially in this one, I did end up having to multiply this entire fraction by this, and then this entire fraction by this, okay? So let's start our multiplication here. Up on the top, 10 times 2 is 20. And then I have an x to the 4th and a b to the 5th. And that's going to be over 90. 10 times 9 is 90. A squared b to the 5th. Now I know you're tempted to start crossing off those b's, but that's going to undo everything that you were just trying to do. We're trying to get the denominators the same, so let that sit for just a second. Okay, and then plus, here 3 times 9 is 27, and then I have a squared and x to the 3rd over, and this should work out the same if I did this correctly. So 9 times 10 is 90, a squared b to the 5th. And so the reason I did that, the whole purpose behind what I just did, is now my denominators are the same. And I can say this is 20 b to the 5th x to the 4th plus 27 a squared x cubed. And that whole thing would be over that one denominator, 90 a squared b to the 5th. And that would be my final answer. If you want to jump this step and go straight to here, as long as you're confident that you've got your denominators to match up, I mean, that's kind of what I did up here, you know, because we didn't change this denominator much. And so that's why I felt comfortable doing that. But if you want to jump over this step, that's okay with me. Again, as long as you're sure that you've got common denominators established. Okay, so this next one is a prime example of what I was talking about earlier, is I really don't want to go over here and just start multiplying by 57. And I really don't want to multiply here by 38. That's going to give me giant numbers to work with. So let's think about what makes 57, okay? And I'm really just picking things. I mean, there are some rules and some kind of tricks to figure out what divides easily into 57, but I'm just going to try some prime numbers. I know that it can't be divided by 2, right? But maybe 3. 57 divided by 3. Oh, and that works. It's 3 times 19. Okay, and I knew I could just write 19 down because 19 is prime. There's nothing else that divides into 19. So this is it. This is what 57 is made up of. Now let's look at 38. 38 I know can be divided by 2. Oh, and look at that. There's a 19 there. So what that means is they both already have a 19. Okay, I've got 19 covered. All I need is for this side to get a 3 and for this side to get a 2. And I know those arrows are going to get off confusing, but I know that on the right side, I'm going to multiply by a 3 and a 3. On the left side here, I'm going to multiply by a 2 and a 2 because that's what was missing from each of these. So now both sides will have a 2, a 3, and a 19. A 2, a 3, and a 19. Okay. And then let's think about our x's and y's. This side has 2 x's, this side has 1, so we need to give this one another one to get them to match. This side has a y and this one doesn't, so this side needs a y to make them match. So on the top of the first fraction, 2y times 13 is 26y. On the bottom, 2 times 57, let's see, that's 114. And then we have x squared y plus 9 times 3 is 27. And then that has an x on it from there. 38 times 3 better be 114, but you can check that in your calculator if you weren't sure. And then I'm going to have an x and an x, which gives me an x squared and a y. I've got my common denominators, which is what I wanted to have happen. And now I can say 26y plus 27x all over 114 x squared y. So I would not have expected you to be able to look at 57 and 38 and go, hey, those both divide into 114, okay? Because I didn't know that off the top of my head. But doing this can help you find your way to that common denominator. And you learned this back in elementary school. You probably just don't remember. Okay, so those can get a little bit tricky. Spend some time on those today, and we'll definitely be talking about them in class when I see you next. All right, have a great day.